Hello, everybody, and thank you so much for joining our session here today. We will be addressing and solving the audio challenges of remote lifestyles. And I am so excited to be here today. My name is Brad Mortensen. I'm a Partnership Development Manager here at Agora. And with me on stage, we have Jim Rand and James Mayer from Synervos. Jim is the CEO of Synervos Communications, a Toronto-based software development company focused on building apps and SDKs to enhance voice and video calls with music, movies, TV, games, live streams, and other interactive components. We help developers solve challenging audio problems, including noise, mixing audio streams, cross-platform issues, hands-free, Bluetooth, and more. Customers include well-established brands like Bose, which we saw earlier today, and Unity, as well as startups building the next generation of virtual hangouts. James, who is also here with me, is the co-founder and CTO of Synervos. His background is in math, computer science, and music. He has a recording studio in Toronto and has spent time as a hacker, white hat, of course, and programmed a wearable DJ rig that let him tour the world while DJing the crowd. Jim and James, thank you so much again for joining us here. We're really excited to hear what you have to say.
All right. Thanks, Brad. So I'm Jim, the CEO of Synervos, and this is James, our CTO. And we wanted to talk about some audio issues that we've been seeing more and more often, partly because of new lockdown-driven behaviors, and partly just a trend toward more interactivity during voice and video calls. So I'll talk a bit about our history, some use cases and projects that we've worked on, some problems that we've seen, including mixing, masking, ducking, cross-platform, Bluetooth issues, noise, echo, and a bunch of other audio stuff. And then James is going to jump in with some approaches to solutions and a live demo. So first, I just want to quickly run through our history to give you a sense of where our audio experience evolved from, in case it helps to draw an analogy to whatever you're building. So James and I met just prior to 2016 when we got into Techstars. And at that time, we had a prototype that let you listen to music together and talk through your headphones at the same time. So let's say you wanted to go running or biking together and you wanted to be able to listen to music, but still talk to each other through your headphones. You could do that. And after some user testing, that evolved into a product that we called Switchboard, which was kind of like an audio Slack. So we had these drop-in audio channels. You had voice commands to switch between them. You could listen to music together inside of those channels. So let me just show you a few quick videos to give you a better idea and hopefully draw a stronger analogy. What you need to do is tap the microphone, and I have an intercom through to Mike. Hey, Mike, what's up?
Hey, Jim, how's it going?
And now we're in a two-way convo. Let me just show you what that looks like from the other direction. So I'll just end this. And now imagine you're just at work, at home, hanging out. Somebody starts talking to you.
Hey, Jim, how's it going?
Respond. And now we're in a two-way conversation. Okay, so there you should have just seen the drop-in audio channels and a voice command, respond. There's a bunch of other voice commands to control the whole UI as well. Here is a second video that just demos some of the music features. So imagine you're just at work listening to some tunes.
Hey, Jim, good call. I love this song.
Now we're in a two-way conversation.
Right on.
So there you should have noticed that the music was ducking whenever Mike was speaking. And I'll just show you one more quick video here that is a very similar use case with video and a Bluetooth speaker in the background. Hey, Mike.
Hey, what's up, man?
And so now you can keep those video connections open without the awkwardness and noise. It starts to feel a lot like you're in the same room, but in this case, you don't have to take your headphones off. So what you should have noticed there was that there was a Bluetooth speaker. It's conducive to like keeping open for a long period of time, but you would have music constantly leaking through the microphone, and there were echo issues to deal with. So it was a pretty challenging use case. I'll just share my screen again here. Cool. So yeah, some of the tech that we used in building that included, we had a voice detector to duck the music when somebody was speaking, and for silence suppression between speaking. We had wake word detection and speech recognition for voice control and transcripts. We had an audio engine for mixing, compressing, and other DSP. We had integrations with Slack and Spotify. We made prototypes with smart assistants like Alexa, Watson, SoundHound, so you could at least talk to robots if you didn't have any real friends to use it with. And we had a bunch of custom audio code to deal with like Bluetooth, noise, echo, and other issues, kind of like music leaking through the microphone or handling audio interruptions from calls or other apps, typing, triggering the voice detector, basically the whole thing being totally unusable if you were outside or in another noisy area. So we solved a lot of those problems and ended up with a pretty cool product, but we were early, the behaviors were super new, and we ultimately determined that we developed a bunch of features more so than a standalone app. And in the future, more and more apps were going to need those features. So in 2018 or so, we pivoted, and our focus is now on developing SDKs and custom engineering for other companies that are doing sort of switchboard-like things. So basically anyone with complex audio issues or where voice and video chat come together with another activity like gaming or watch parties or listening to music together, that's our bread and butter. So if you think about products like, Clubhouse or Slack Huddles or the sort of new lockdown-driven spatial audio apps or virtual spaces and events platforms, the more interactive they become by adding sort of games or music or streaming video and other activities, the more flexibility they're going to need in the audio pipeline. So I'll run through some examples to illustrate why you might need that flexibility and how Agora helps. So first, if you want to transform the audio, you're going to need access to it. So if you can't access the microphone samples, you can't run DSP processes on them. And not all SDKs give you that, but Agora does give you raw audio to both locally and remotely. So you can do whatever transformations you want. And as of today, the extensions marketplace actually makes that even easier with some pre-made effects like noise canceling and voice changers. So it's worth checking that out if you get a chance. And similarly, assuming you need to mix another audio source from music, a game, or a video, you also need to consider whether you have access to the raw audio from those. So remember in the video demo that we saw, we were ducking the music when somebody would speak, and Spotify's old SDK actually gave you access to the raw audio so we could compress it, but the newer App Remote SDK doesn't. So we had a workaround where we used Spotify's web API to send ducking signals through a user's Spotify account, and then they killed that endpoint, and we had to find other workarounds. Watching YouTube together was another example where we could duck the volume on the web, but there were limitations on iOS. And there's a bunch of other examples, but suffice it to say that your solution and constraints are going to depend on where your audio is coming from, and you're going to want to consider early on whatever is possible with the APIs and SDKs that you're planning to use. Another thing to think about is the relative volume level of each audio source. So not just normalizing the microphone volume across users, but the level of voice versus the music or the movie or the game. So, in a multiplayer game, you might be able to rely on spatial audio and movement in the game to help distinguish multiple audio sources and determine the relative loudness. But if there's music or a watch party, then there's constant background audio that masks the voice. So you might need some form of ducking like you saw in the video. But even when you do that, what happens when you stop talking? So does the volume jump back up mid-sentence after 1 second, or is it after 5 seconds? How smoothly does the volume ramp down and ramp up? Do you want to duck all frequencies equally or only a certain part within the voice band? Maybe you want to reposition the audio rather than duck. So ultimately, you're going to need an audio system with some flexibility to accomplish that. Another problem that we run into is constraints on the input or output device. So for example, if you have a Bluetooth speaker or headphones and you need to play music, you need to use the A2DP profile, or else the sample rate is going to be too low and the music quality is going to be horrible. But A2DP only gives you one way, so you can't simultaneously access the microphones, meaning you can't hang out with an open mic and your voice commands aren't going to work. So another example would be, if you're working with a smart speaker, Amazon or Google might not let you hold the microphone open for a voice call unless you're a major partner like Skype. So you end up with workarounds again. And one of the ones that we've used is to use the microphone on your phone simultaneously with a Bluetooth speaker output. But then you have to deal with echo issues in a setup where the microphone distance is constantly varying with respect to the Bluetooth speaker, or the distance between the person and the microphone is varying. And there's an awkward sort of UX that you have to train users on. So device combinations can get pretty messy. OS-specific issues are another pain in the butt, and there's too many of those to talk about, but James is going to talk about why you'll likely want a C++ core with specific wrappers for, say, iOS, Android, or WebAssembly. And there are other constraints kind of depending on both the hardware and the environment, like limited compute on old Android phones, which might limit what machine learning models you can use, or cheap microphones, rooms with lots of reverb, or maybe not enough reverb if you want it to sound like you're in a particular type of space. So depending on your use case, all of these things can be solved for, and that's where I'm going to hand it off to James, because I mostly have problems and he has the solutions. So I'll just stop sharing my screen here, hand it over to James.
All right. Thank you. So, I'm James, the CTO. Thank you to Agora for giving us the opportunity to talk about the technical problems of remote lifestyles. Jim outlined the problems for you, and I'll go ahead and outline some of the tools, techniques, and approaches that we've used to solve them. Most of our audio processing happens on the send side. In my recording studio, we have a saying: it's better to get it right when recording than to fix it in post. This diagram shows how expensive it can be in your system if you're fixing these things on the receive side. On the other hand, editing music lacks some of the challenges of editing a video or voice call, the hard real-time constraints, and the single shot to get things right. That leads us to our first technology choice, C++. This gives you the speed, and it gives you the portability. In the pipeline shown here, the parts in yellow ideally are in C++. It's best to do the hard work like FFTs, analysis, and prediction or feature detection at this low level. Then you wrap your C++ engine in Swift, Kotlin, Java, or another high-level language, since once you have all the hard work done, you can afford these interpreters and virtual machines. If you don't handle the audio at a low level, you'll miss deadlines filling up buffers before they play, which can cause all sorts of audio artifacts. Nowadays, there's also tooling that'll let you compile your C++ code to WebAssembly so you can start approaching C++ bare metal performance in the browser. Another choice we often have to make is leveraging frameworks like Superpowered and Juice. They save you time by giving you a common audio interface to multiple operating systems. They help us out at the points in yellow. Those are the points where you're interfacing with the VoIP SDK and also where you're interfacing with the operating system. They're both great tools. My preference is Superpowered, but it depends on what you want to build and how you feel about the various open and closed source licensing models. They both assume some level of audio knowledge, but feel free to reach out if you have any questions about them or any of the other frameworks that are out there. And Superpowered is actually doing some very interesting things with WebAssembly, so you can get some of those performance gains using their tooling. Another thing that Jim mentioned was access to raw microphone audio. For simple voice and video calls, you really don't need it, but sometimes calls aren't simple. Maybe you want to make it sound like Carnegie Hall with some reverb. Maybe you need additional noise canceling. Maybe you need a voice filter. In those cases, you will need access to the microphone signal to change it. Agora gives you these two functions to push and pull samples into and out of their SDK so that you can incorporate Agora into your audio pipelines. Alternatively, as of today, there's now an option to add audio extensions into Agora's pipelines. So for example, there's a new noise reducing extension called Bose Pinpoint, and there are also other extensions for changing your voice or adding effects like reverb or echo. Jim also mentioned the Spotify Web API, and I wanted to show that in the context of an audio pipeline. So we can use the audio processing on device to make inferences, such as whether the user is speaking, and then send control signals out to the cloud or other part of the app to achieve some desired effect. This setup might make sense for a number of reasons. For us, it was to detect and duck music. Another example might be to send out a notification when a particular sound is recognized, or to detect someone's presence in the channel by virtue of their voice being detected. Another thing to consider is that you're going to have more than one possible audio pipeline. So there are states and transitions to be mindful of when setting up your pipelines. Setting up these transitions is one approach to solving the Bluetooth problem Jim alluded to. For example, if the user starts playing music, then you want to transition to the A2DP pipeline because you need the 48 kilohertz sample rate for the music. But when the user stops playing that music, you might want to transition back to the HFP pipeline to make use of the microphones on the Bluetooth device. There's many other possible states and transitions that you're going to need to consider, like whether the microphone's on or off, input and output device availability, and so forth. So making some charts and really thinking through things is a good idea as you need to use these different pipelines. Finally, there's the two big bads that we all face, noise and echo. These are extra devious because typically the person causing the problem isn't aware that they're sending it onto the wire. And when it comes to echo cancellation, even Google hasn't yet solved for all the scenarios, as evidenced by the recent tweak to Hangouts, which tells you to mute yourself when you're causing an echo. Hopefully, though, muting yourself will soon be a thing of the past. Deep learning is being used to address both noise and echo, and the results are far better than traditional noise and echo suppression. From what we've seen, deep learning-based echo suppression isn't quite commercialized yet, but it is getting close. That said, noise reduction is further along. Something we're super excited about is the Bose Pinpoint extension, which uses deep neural networks to reduce noise. And let me show you why it is that we're excited. So right now, you can hear me clapping, and you can hear me snapping. When I go ahead and I turn on Bose Pinpoint, and I snap again, and I clap, now you can only hear it or hear me when my voice is present. That, however, is not the best demonstration, so let me go ahead and move outside. All right, so I'm going to take a little trip outside to the balcony of this Miami apartment that I'm staying at.
All right.
You're going to get a little bit of the sounds of the city.
I think we can hear the sounds of
Coming
the
in.
city there.
Do is indicate point that it's time to turn the noise suppression on. And there we go. Noise is canceled.
Yep, you're there. I'll keep talking to you for a second here just because it's taking your video a second to catch back up. I think you lost Wi-Fi signal a little bit, but why don't you turn it back off for a bit, show us the noise again, and then turn it back on again. Yeah, okay, that's pretty good.
All right,
I can hear it there.
Yeah. As it stands right now, you're hearing a little bit of Miami afternoon. The rain has stopped. The sun is shining, but there is a bit of noise coming in. Now that I've got the noise filter engaged, you should just be hearing my voice.
Right on. All right, yeah, I mean, I'd say that's probably it for the demo. We might as well open it up to Q&A. I mean, we bulldozed through a lot of stuff there, so there are likely some questions, so we might as well open it up. I'll also just share my screen here quickly so that you can have our contact details. And that is, there we go. Cool. So, yeah, have we got any questions?
Jim, James, thank you so very much. James, I love the interactive demo that you did there and being out on your balcony there. Very, very cool. That's awesome to hear. Couple questions for you, right? I am curious, right? There's a lot of software as a service out there with these set expectations of what the landscape is today. This is kind of a business question, but bear with me here, right? When you're looking at a solution or working with a client of yours from a Synervo's perspective, how do you help them understand what's possible in fighting against the status quo of what you see in, let's say, Teams, Zoom, Meet, so on and so forth?
Yeah, I mean, I guess there's kind of different ways to answer that. So, I mean, if they've got a very specific problem that they're trying to address, if it was just noise canceling related, I think kind of something like the demo, we can kind of show them, hey, here's what's possible very easily, right? When it comes to use cases, I mean, I have those conversations all the time, I guess, where, it's like, people would try to use Zoom for a watch party, for example, and it would be an awful sort of use case because, you always had noise leaking through, from the movie or whatever you were trying to watch together. And so we had our own sort of demo apps that we would show like, hey, look, this is how much better it can be if you actually integrate, the media player together with the voice or video chat service. So, I mean, we've built a ton of prototypes. We've built our own internal apps, our own internal SDKs. We use them a lot for demos or even as a starting point to helping customers solve their problems. But yeah, there's just a ton of new use cases, I think, that are now possible, not just with, the fact that people are inside and needing them more often, but because noise cancellation and other kind of audio tech has gotten to the point where it makes those use cases feasible. You could never keep an open mic for a long period of time before. It just got too noisy or you'd have to manually mute and unmute yourself. And so that makes a lot of use cases not terribly feasible, but I think you're going to see a lot more behaviors now that you can kind of keep an open mic for an extended period of time.
Awesome. Thank you, Jim. Thank you. A couple questions from the audience here. The first one we have is, what is the current state of spatial/stereo support on AirPods and other Bluetooth headsets when in communication mode?
So, I mean, right now, I think it's independent of, and correct me if I'm wrong here, James, but I think it's kind of independent of what kind of headset you're wearing. I mean, it's more about what you support in the app. And so, yeah, you can do it. You can, go ahead.
I'll take the rest of this. A lot of the spatial audio solutions these days just are able to present that to you as long as you have a stereo pair making it to the user's ears. There are, of course, certain extras that you get in specific pieces of hardware, like the most recent AirPods. But there are also a bunch of solutions out there that can give you the spatialized experience as long as you're wearing any stereo headphone. Now, of course, when you're having to do noise reduction, that's going to cost you twice as much because you have two streams in that case. If you're doing it on the receive side, so that's something to think about as you start spatializing your signals. Is you want to make sure that they're spatialized, the noise is reduced when they're mono, and then you're getting them into the spatialization in the stereo pair or some other multiple speaker setup.
Great, thank you both very much. Next question here from the audience. What latency in audio is there when noise filtering or audio ducking are engaged?
Tens of milliseconds. It kind of depends. James, you've probably seen the measurements more than I have, but
yeah. So ducking is very close to instantaneous. We're talking about 16 or 32 samples, whereas the noise filtering is going to add maybe 6 on some models and up to tens of milliseconds when you're using more complex and needing to extract more expensive types of noise.
Very cool. Rolling into the next question here, what type of use cases do you see benefiting most from better noise cancellation?
Yeah, so I mean, kind of like I was saying earlier, I think that the persistent open mic use cases are going to benefit a lot. So if you think about, virtual worlds, maybe you're in a virtual office and you can kind of keep your mic open the whole time. And now it starts to feel a lot like a real office because you can just sort of talk, or you can walk over to somebody and just talk, and you don't have to worry about manually muting and unmuting yourself, which really kind of takes away from that experience and doesn't allow you to just sort of keep the thing open in the background while you're otherwise working. So I think any sort of persistent mic applications are going to benefit a lot, and you're going to see a lot of new behaviors evolve around that. That kind of extends into any metaverse-like application. Then there's all the sort of, where you see a lot of noise, mobile type use cases. So imagine people on a construction site, and you've got sort of a solution that replaces walkie-talkies. or, in my case, I'm a motorcycle rider, and so it's going to improve communications between motorcycles or you and the passenger on the back. Or if you're a cyclist, the wind noise and trying to stay in communication with the others that you're biking with. So there's just a ton of new use cases that haven't been feasible, and I think a lot of them just sort of revolve around that ability to keep a mic open and chat spontaneously throughout an experience.
Yeah. And especially as remote lifestyles are becoming more and more of a thing, not having to be concerned that, I want to go out to the balcony in the middle of a presentation, and not have the change in the audio, profile of the area that you're in change. And as you can, take your mobile and, go out into the city and have conversations in the middle and not care about, the cars that are driving by. But then also, sort of on the receive side, just have those experiences being made better for the people that you're communicating with, without you necessarily knowing it, I think is going to, bring communication up another notch, ratchet it up.
Watch parties are another one that come to mind, right? So, I mean, it's another open mic sort of scenario where right now people just text and type back and forth for the most part because muting and unmuting yourself is a pain, or there's otherwise just sort of too much noise in the way.
Very good. Thank you. We have a non-technical question in our chat from William here. I'm going to paraphrase a little bit, but he's referencing back to the Spotify example that you had there, Jim, where you were injecting music into that listening scenario, right? Where you were listening with others. How does that work from like a legal perspective? If, let's say, for instance, that other listener doesn't have a Spotify subscription or something of that nature?
So there's a couple ways to answer that. In that use case, both users did have a Spotify subscription, and it's actually a Spotify premium subscription, and we're sending signals back and forth to sort of synchronize what they're listening to each from their own account. So that's one way to do it. Anything like a screen share or an audio share where I'm kind of doing something on my device and then sending the packets over to you, that's another way to do it. And that was possible with the old SDK. It's not possible with the App Remote SDK. And those legal concerns were one of those things that came up. We've had those discussions with a lot of different content companies, and they worry about, anything where you've got, one user who has access, who's kind of sharing it out to many others who don't necessarily have access. And there's, if one user has access and shares it with a couple friends, there's a bit of a gray area to play with there because, you're allowed to have somebody over to your house and you can all watch your TV in the living room. But as soon as you start broadcasting publicly, like that's an absolute no. And so there's sort of a gray area in between that, you still have to play with depending on your use case in the app that you're building. But happy to chat more offline about that.
Yeah, awesome. It's definitely something where with Spotify, they're handling the licensing. So if we're integrating the Spotify SDK and we're making sure that only authenticated Spotify users are accessing that SDK and those music streams, we're everybody can kind of piggyback on those licenses, and that's why not everybody has to have these deals with all the big music producers.
DMCA, look that up. That's something that will be relevant to understand.
Awesome. Thank you. That goes back to my VHS days where you see that FBI warning in front saying I'm not allowed to charge my friends to watch Star Wars with me or whatever it may be.
Home taping is killing music.
Yeah, right. Yeah, exactly. We have a fun question here. Justin from the chat is curious how many nights sleep he's going to lose or sacrifice in order to integrate your SDK here.
Not a lot.
Yeah, the Bose Pinpoint extension, maybe half a night. Our SDKs are maybe a couple days, and no sleepless nights. It's a party.
Awesome. Well, Jim, James, thank you so very much. It was a real pleasure having you come on stage here and speak. And James, thank you for the brief tour and letting us hear the soundscape that was canceled out very nicely. Jim, always a pleasure as well in hearing your knowledge and sharing what you have. For those of you listening, stay tuned and stick around on this technical track as we will be talking in a couple other sessions coming up learning more about multiplayer spatial audio in first-person training, in addition to Zoom fatigue to avatars and understanding the future of communication. So thank you all again very much for joining this session. A big shout out to Jim and James from Synervos, and we hope to see you at other sessions. Thank you all for your time.